Welcome to the first video of hopefully many in which you will gain a more in-depth understanding of the scientific discipline known as chemistry. Now, what we're going to be talking about in this video is what exactly chemistry is and what the foundational area of study is in the chemistry discipline. So chemistry, unlike physics, concerns itself with matter. So matter, the scientific definition for which is anything that has mass, meaning you can weigh it in some way and find how many grams or how many kilograms it weighs, as well as anything that occupies space, also known as volume. Now, we need both of these definitions here because there are certain substances, such as the air that we breathe, where measuring the mass is difficult, but we definitely know that the air that you breathe is there because we would all be dead without the oxygen in the air, and we can definitely describe that the air has volume because it takes up space in the room where we exist and in the atmosphere of the Earth. Now, when we discuss chemistry, we need to discuss the foundational unit of chemistry, which are what we call atoms. So atoms are the unit that all matter that it composes the Earth and everywhere that we live in is made of. And if you take any substance, whether it be the handout that you're writing this note on or the pencil that you use to do your writing, and break it down into small enough pieces, eventually when the pieces are microscopic, so small that you cannot see, you will have atoms. Now, atoms are obviously invisible to humans because they are so small. In fact, the word atom from the original Greek literally means indivisible, meaning that atoms are so small that you can no longer break them apart and still have them be the fundamental unit of matter. And depending on the structure and composition of a specific atom, groups of similar atoms that share exactly the same structure and organization are what we call elements. And elements determine what type of atom, or rather, the type of atom determines what element you are looking at. And some elements are examples of substances that we interact with on a day-to-day basis. For example, all of us are alive because of the oxygen that we breathe. Oxygen is one example of an element. Another example would be nitrogen. This is another gas that exists in the atmosphere. In fact, most of the gas in the atmosphere is actually nitrogen rather than oxygen. That's actually what explains why the sky appears blue. But then for more tangible elements that we can actually interact with, many of these are metals, such as iron that we use to make tools or potentially weapons out of. Elements like gold have very specific properties that make them expensive, and closely related to gold is, of course, silver. All three of these are also examples of single elements, which are what we call metals, but we will explore that in a future video. Now, the second half of this video, we're going to learn about the structure of what atoms actually look like if we could visualize them. Now, obviously, you will never be able to see atoms because they are so incomprehensibly small. So instead, we represent them with diagrams that we call Bohr diagrams, or rather, more fully, what we call Bohr-Rutherford diagrams, referring to the two physicists that came up with discoveries that helped us shape what this simplified structure of an atom looks like. Now, we need to get a little bit of terminology in terms of what the different components of an atom are. So there's going to be a little bit of vocabulary here, but we're going to start in the center of the atom and gradually work our way out. Now, the word that we remember for the center of the atom is what we will call the nucleus, and you can remember this word because it's where we get the adjective nuclear, referring to nuclear power and nuclear bombs from, because the energy that powers both nuclear weapons and nuclear bombs electrons is energy that is stored in the center of the atom right here. Now, the nucleus and all of the surrounding areas are made of three different types of what we call subatomic particles. Now, a particle is just something that is very, very small. Technically, you can use the word particle to describe an atom, but when we say a subatomic particle, sub implies that we are looking smaller than an atom, because atoms are made up of three different smaller than an atom particles, two of which we find in the nucleus. So this shorthand here, P with a positive sign, is a shorthand for protons, and the positive sign here is an indication of something that we call charge. Now, charge, we may make the comparison of charge by looking at something like a magnet. Now, magnets have two locations on them, which are what we call poles, what we call a north pole and a south pole, although more accurately, magnets are said to have a positive pole and a negative pole, which determine how the magnet is going to behave. Now, magnets function because they are made of atoms, and because the protons within the magnet have a positive charge. Now, the other type of particle in the nucleus are what we call neutrons, and we can remember the word neutron because this is where we get the English word neutral from. Now, something that is neutral is neither one thing nor another thing. For example, if we use the word neutral during wartime, a country that is neutral does not take either side during a war. So we say that neutrons are neutral in terms of their charge because they have no charge. They are neither positive nor negative. Now, the second descriptor we need for each of our subatomic particles is what we call the atomic mass. And mass is important because mass is what defines whether something is matter or not. Everything that we study in chemistry needs to have mass, and fundamentally the mass of a substance is based on the number of protons and neutrons that substance has. So a proton is defined as having a mass of 1 unit, and a neutron is also defined as having a mass of 1 unit. And together, protons and neutrons make up what we call the nucleus of atoms, which brings us to what we find on the outside. So the red particles that we see here are much smaller particles that we call electrons. Now, electrons are opposite to what we consider protons, and therefore, because protons have positive charge, we define electrons as having negative charge, and that's why the short form for electrons are E with a small negative sign at the top like this. Now, electrons are significantly smaller than the nucleus, and the protons or neutrons within, which is why we say that electrons have approximately, the squiggly equal signs means not exactly equal, but approximately equal to 0, meaning that electrons are so small that they basically do not have mass. Now, obviously from the diagram, we can see that electrons travel outside of the nucleus in these regions of space. So these are not actual physical structures. They are simply areas of space outside of the nucleus, and they go by a couple of names depending on who your chemistry teacher is. Some would refer to them as orbitals, although this term is not used correctly until we get to a more detailed structure of the atom. So the more common name that is given to these areas where electrons can move are what we call shells, although most teachers will refer to these as what we call electron shells. Now, we're going to get a little bit technical here, so make sure that you can follow along. The shell that is closest to the nucleus is what we call the first shell, because when we move from the nucleus outward, it's the first area where we can find electrons. Now, here is the technical bit. After the first shell, we have the second shell, because it is the shell that comes after the first one. And if you had a shell after the second shell, that would be the third shell. etc., etc. Now, sarcasm aside, the one specific name that we need to remember is not for a specific shell, but for the electron shell that is found outermost. So this is the shell where if you draw a line from the nucleus to the electrons that are farthest away from the nucleus, so that would actually be here, this is the shell that we define as the outermost shell because it is farthest from the nucleus, and the name that we give to this is what we call the valence shell. And if you remember one thing from the structure of the atom, remember the word valence shell, because this is going to come back over and over again with every level of chemistry that you do. This concludes this first introductory video. In the next video, we're going to be introducing the most commonly used organizational system for classifying and describing elements, which is what we call the periodic table. So join us as we talk about that in the next video in this series.